All right, good morning. We're going to try Introduction to Trigonometry today. SOHCAHTOA. Hopefully this first part is a review from geometry class. Trigonometry, tri, like a tricycle, three. Gon, that's, I believe, the Greek word for side. So three side, metri, measure. So it's the study of the measure of the three sides of a triangle. Trigonometry really just has to do with the ratios of the sides in a right triangle. So here's my little right triangle over here. And so we find out that sine is opposite over hypotenuse. So the ratio of the red to the black. So in the cosine, we're taking the blue, we're taking the ratio of the adjacent to the hypotenuse. So adjacent over hypotenuse, that's the ka. And then tangent. All right. In the tangent, you got opposite over adjacent. So the ratio of the red to the blue, that's the TOA. And one other thing I'm going to mention about tangent before we go on, because I probably won't talk about tangent as much as I'd like to. The opposite, that's the rise. Please see the red goes up and down. And then the blue, that's the run. So tangent is rise over run. Tangent we can associate with slope. File that away. All right, now we go to special right triangles. You should remember these from geometry class. One of them is when you take a square and connect the opposite diagonals, you make a isosceles right triangle. So this side's x, this side's x. Using Pythagorean theorem, we find out that's square root of 2x. And then in here in the purple one, all right, this is equilateral triangle. So this side's x. Using symmetry, we can see 1/2 x is down here. And then using Pythagorean theorem, we can figure out the height of the triangle, or the last leg, the longer leg, is square root of 3 over 2. Now I go back over here. This was the unit circle. Please see there's a 1. So that's 0, 1. There's 1, 0 over there. So if I make the hypotenuse 1, so if I let, in this example, x be 1, in this example, square root of 2x be 1, I can go backwards and figure out what those are. So on the unit circle, the hypotenuse is 1, so that means, the x coordinate is the same as the cosine of the angle, and the y coordinate of the point on the circle is the sine of the angle. Remember, x comes before y, and c comes before s. So the x goes with the c, and the y goes with the s. You can use a little mnemonic to remember that. All right, next. All right, so now here we are in the unit circle. So each one of these hypotenuses, each one of the radii of the circle is 1. And so we can go ahead and we look in here. Now, I'm going to use degrees first. So that would be a 30. There's the purple one. That's a 30. The green one's going to be 45 degrees. And the other purple one is going to be 60. Please see the two purples are congruent. It's just turned up on its short leg for this one over here. So if we do cosine of pi over 3, we would get a half. And if we did sine of pi over 3, we would get square root of 3 over 2. All right, and remember, quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negatives. Because if you can just remember the 3 points over here in quadrant 1, when we take them over into the other quadrants, the only thing that's changing is the sign. So here comes the unit circle. This used to be a quiz I gave. So there's 1/2 and square root of 3 over 2. Please see there's only 3 types of numbers in here. The sign changes, but it's 1/2, square root of 2 over 2, the square root of 3 over 2. And the square root of 2 over 2, it always just goes with the square root of 2 over 2. It's the same every place. The 1/2 and the square root of 3 over 2 go together, and you just got to figure out which one goes first. So over here, everybody's positive, and then you look. If I take this point and flip it over here, I reflect it over that y-axis, I get the same coordinates. The only thing that changes is the sign. So I'm going to get a negative here with the x coordinate. All right, and that's the unit circle with all the measurements put in there. I think that's okay.